Okay, so here we go. Our objective for today, I can solve and graph quadratic equations. I can solve and graph quadratic equations. Let's read it together. 1, 2, 3. I can solve and graph quadratic equations. Now, this is where it's going to start getting interesting. It's going to be fun-er. So today I'm just going to show you a couple of things. We're not going to get too much into the graphing, but I just want to show you the connections of everything. Okay? So once again, I can solve and graph quadratic equations. Our concept for today is quadratic equations. Quadratic equations. That's what we need the FAIR model. Okay? So with that said, quadratic equations, what are they? Definition. Two variable equations where the highest degree is 2. Two variable equations where the highest degree is 2. Two variable equations where the highest degree is 2. Example. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. And y equals 3x squared minus 11x plus 6. Write those down, please. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. And y equals 3x squared minus 11x plus 6. All right, so let's see. Okay, pens down really quick. You'll finish copying right now. I just need your attention so I can connect the definition with the example. The definition says two variable equations. Let's see. Is this an equation with two different variables? How about this one? How about this one? Yes. The highest degree is 2. Let's look at this one. What is the degree of this one? 2, 1, 0, 1. So the highest degree is 2, and so on and so forth. Everybody with me? All right. So that's a quadratic equation. So compared to what we were doing before, now instead of looking at expressions, what are we looking at? Equations. So let me give you non-examples. Write these down. Non-examples. First non-example, x squared. Next non-example, x squared plus 3x plus 2. And the last non-example, negative 3 plus x equals 10. So think about it. If these were the examples according to the definition, why are these non-examples according to the definition? Think about it. Okay, share it with your neighbor, please. To understand about quadratic equations, the critical attributes are that they are two variable equations, and the highest degree is 2. So yes, so this one's an expression, equation, but it doesn't have the highest degree 2. Okay, steps, copy these down, please. Okay. Six steps. Step number 1, substitute 0 for y. 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 Step 2, factor the trinomial. Factor the trinomial. Factor the trinomial. Step 3, set each factor equal to 0. Set each factor equal to 0. Set each factor equal to 0. Step 4, solve for the variable. Solve for the variable. Solve for the variable. Step 5, graph. In parentheses, write using the x-intercepts and the y-intercept. Using the x-intercepts and the y-intercept. And number 6, check. Check. So once again, step 1, substitute 0 for y. Step 2, factor the trinomial. Step 3, set each factor equal to 0. Step 4, solve for the variable. Step 5, graph using the x-intercepts and the y-intercept. And step 6, check. All right, words to circle and underline to remember. Step 1, substitute 0. Bless you. Substitute 0. And the only variable there that they have to substitute is y. Step 2, factor. Step 3, set each equal to 0. Set each equal to 0. So once you factor, set each equal to 0. Step 4, solve. Solve, graph, and check. It's fairly simple. Fairly simple steps. There's multi-steps within some of the steps, but we already know how to do all these. And as promised, you guys notice that the steps have been accumulating little by little? Yay! So that's why it's going to be fun-er. All right? So let's see. Once again, step 1, substitute 0 for y. Step 2, factor the trinomial. Step 3, set each factor equal to 0. Step 4, solve. Step 5, graph. And at the end, check. Okay? So now, before I get started, I want to make one thing clear. Let me move on really quick. Pens down, eyes up here. I just need your attention. Question. What if I said 2 times 0? What is that? What if I said 0 times 2? What if I said x times 0? What if I said 0 times x? Okay, what if I said this? A times b equals 0. Don't say it out loud. And I ask, what could A be? Well, question here is that if the answer is 0, one of these two has to be what? So A could be 0 or B could be 0. Is that correct? 0 or any number. Are we there so far? Same thing if I gave you this. A times B times C equals to 0. One of these three has to be 0. Is that correct? Everybody following so far? Okay. This property is called the zero product property. Which states that a number times 0, the product is always 0. It doesn't matter how many numbers you multiply. If one of them is 0, the product has to be what? Copy these, please. So everybody understands the process, right? That if we have variables here, one of these variables has to be 0, and it could be either A, it could be B, or it could be C. One of the three has to be 0. Is that correct? Okay, think about that because we're going to need this property in order to work on the next step. Here we go. So example number 1, copy this down, please. Example 1, copy the words. This is the only time you copy the words. Solve the quadratic equation by factoring. Check your answer. Solve the quadratic equation by factoring. Check your answer. And the equation they give us is x squared minus 6x plus 8 equals y. Solve the quadratic equation by factoring. Check your answer. X squared minus 6x plus 8 equals y. As soon as you copy that, pens down, and I'll go over this. So pens down, eyes up here. I'm going to go over this step by step. Please just pay attention because there's a lot of things that are going to be happening, and I just want you guys to get the whole idea. Okay? Here it goes. So everything that we've done up to this point, now you're going to see how it's going to work in this equation. So focus. Step 1. What was step 1, Rhett? Everyone? Substitute 0 for y. So check this out. Instead of writing y in my first step, I'm going to substitute 0 in there, and I'm going to rewrite everything the same. Step 2, factor the trinomial. Is that correct? Okay, so check this out. Everybody look up. If this was an expression like this, do we know how to factor that? Yes. So therefore I do the following. I check for GCF. Do I have any GCF? No. I open two parentheses, and then I factor the first term, x and x. Get my Power Ranger going. Negative 6 goes down here. That's my sum. My product is 8. What factors of 8? 4 and 2. Let's see. But this is a negative. This is a positive. That means that both of them are negative. So this is x minus 4, x minus 2, and bring down the equal and the 0. Okay? Step 3. Read that, Jesus. Set each factor equal to 0. So pay attention to this part. Everybody look up. Stop writing, please. This is where this kicks in. We have two factors here, don't we? A and B. What could A be? Or what could B be? So that means I need to write this. A equal to 0 or B equal to 0. Is that correct? So now check this out. Look at this step. What could this, these two are multiplying, right? And if the answer is 0, this could be, or this could be. That's why we need to write these x minus 4 equal to 0, x minus 2 equal to 0. Step 4, Roberto. Okay, so what do I do here? Add 4, x equals 4. Right here, add 2, x equals 2. Yeah? What's that? You just do the opposites, yeah. Okay? And these are called roots. Or in Algebra 2, they're going to show you that these are called the zeros. Copy that, please. Okay, so as you're finishing copying that, let me see. Step 1, change the y into 0, or substitute 0 for y. Step 2, factor the trinomial. And we know how to factor it, right? Check for GCF, use the Power Ranger, so on and so forth. Step 3, set each factor equal to 0 and solve. There it is. Step 5, what is step 5, Jose? Graph. Okay, so check this out. Pens down, eyes up here. This is the connection that I want you guys to make. I'm going to get my coordinate plane. And why am I getting the coordinate plane? What kind of equations are these? Two variables. Is that correct? Two different variables. And what do we use to graph two different variables? The coordinate plane. So here we go. This is my y-axis. This is my x-axis. Check this out. These are called zeros for a purpose. What number is this? 4. X to the x4 is about right here. Because if I plot that point, x is what? 4. And what is y? 0. That's why they're known as zeros. Let me show you this one. What is this point? 2, which is right here. And my coordinate there is what? 2 and 0. That's why they're called zeros. Are we there so far? Now check this out. Everybody look up, please. Pens down, look up. Look at this one. Right now we're dealing with quadratic equations because it has the highest degree of 2. However, back in the first semester, we graphed stuff that looked like this, didn't we? Okay, and what is this last part of the equation called? The y-intercept. Remember that? This was the slope, and this was the what? The y-intercept. Remember that? So if that's true, check this out. If that's true, my y-intercept for this equation is positive 8, which is up here. Is that correct? And what that graph looks like when we got into quadratics, the graph for quadratics are known as parabolas. So our graph looks like this. Check this out. Copy that, please. Here goes the entire process. Step 1, substitute 0 for y. Step 2, factor. Step 3, set each factor equal to 0. And what is that property called? Zero product property. Or I call it ZPP. You guys have heard that song? You down with ZPP? Yeah, you? No, never mind. All right. And then if we solve this equation, we solve that. What are these called? They're called the roots or zeros. Okay? So make sure you remember that. Those are the roots or my zeros. My roots or zeros. Okay? And the last step, check. How do we check? We get each value, substitute it in here, and see if it gives us 0. Let's see. Let's substitute the first one. 4. What is 4 squared? 16. What is negative 6 times 4? Negative 24 plus 8. Can we combine the positives? 16 plus 8, that's, what is 24 minus 24? Boom. Okay, here it goes again. I'm going to substitute the 4 into our equation here, right? Okay, here it goes again. Let me show it right here. X squared plus, minus 6x plus 8 equal to 0. I'm going to substitute the first value, which is what? 4 squared minus 6 times 4 plus 8 equal to 0. This is 16 minus 24 plus 8. If I combine the positives, this is 24 minus 24. Is 0 equal to 0? Yes. We do the same for the 2. Check this out. If I substitute here, the 2 is 2 squared minus 6 times 2 plus 8. What is 2 squared? 4 minus 12 plus 8. Can I combine the positives? Yes. 12 minus 12 is 0. Is 0 equal to 0? Yes. Therefore, both of them work. So we got it? Lengthy process? Yeah, right. Let's do one together. Copy this next one. You don't have to copy the words, just the equation. Here we go. Example number 2. Y equals x squared plus 7x plus 10. Y equals x squared plus 7x plus 10. Okay? Turn to your, let them know the first step. Yes, sir? If you want. Right now I'm not quite there. I just want to make sure that you guys see the connection. Here we go. So we substitute y for 0, okay? Step 2, what do we do? Factor. First, we're going to check for GCF. Do we have any GCF? No. So then we open 2 parentheses. And we factor the first term, which is x and x. Get our power rangers. 10 is our product. 7 is our sum. Turn to your neighbor and know those factors. 5 and 2. Positive 5, positive 2. Bring down the equal and the 0. Next step. Michael. Bam. X plus 5 equal to 0. X plus 2 equal to 0. And we solve. So what do? X equals negative 5. X equals negative 2. And these are called the roots or zeros. Okay? Next step. Jorge. Graph. So let's see. We get x is negative 5, which is over here. Plot your point. The other one, x is negative 2, which is here. And turn to your neighbor, let them know what the y-intercept is of that equation. Positive 10. So therefore, there's our graph. Make sure you put arrows at the end. And can we check it? Yeah. 0 equals x squared plus 7x plus 10. Let's check the first number. The first number is negative 5 squared plus 7 times negative 5 plus 10 equal to 0. What is negative 5 squared? 25 minus 35 plus 10. Can we combine the positives? Yes. 35 minus 35, 0. So that is true. Let's do the other one. This is negative 2, so I'm just going to rewrite it over here. Negative 2 squared plus 7 times negative 2 plus 10. So this is 4 minus 14 plus 10. Can we combine the positives? Yes. So this is 14 minus 14, 0 equal to 0. That's also true. Pretty simple? Yep. Okay. Yeah. For the homework, what is the answer? The answer, number one, they're going to ask you to factor it or to solve it. The solution, guys, when you solve a quadratic, are your zeros. These are your, this is your solution. Your zeros are your roots. Okay? But what I'm asking you to do, go one step further and graph it so you guys can start seeing the connection. Okay? So are you going to graph all of them? No. I want you to graph at least half of them. Okay? Let's do another one. Copy this one. You do this one by yourself. Y equals 2x squared plus 4x minus 30. Yx squared. Y equals 2x squared plus 4x minus 30. Go. Okay, get me started, Omri. What do I do? Substitute 0 for y. Pass it to someone else. Mel, what's my next step? Oh, Alyssa? So the factor, but the greatest common factor is 2. So let me see what I'm left with. X squared plus 2x minus 15 equal to 0. And can we factor this one right here inside? Yes. Pass it to someone. Cool. Jorge. Very good. X and X. And get your Power Ranger. Negative 15 and 2. And he said 5 times negative 3. Yep. So this is x plus 5, x minus 3. Pass it to someone. Brianne? Okay, so tell me the step. Set each factor equal to 0. So how many factors do you see here? 3. Is that correct? 2, x plus 5, and x minus 3. So I'm going to set each one equal to 0. 0 equals to 2, x plus 5 equal to 0, and x minus 3 equal to 0. Is that correct? Yes. That was the step, wasn't it? However, everybody look up. Is this true? So therefore, we don't use this one. We already got rid of the GCF. We sent the BFF to his house, right? So, but we can solve this one, can't we? Yes. Minus 5 minus 5, x equals negative 5, plus 3 plus 3, x equals 3. What are these known as? The roots or our zeros, and those are my solutions. So up to there, we're good. Next, pass it to someone, please. Oops. Sabrina, okay. Graph, okay, tell me what to do. 3 and negative 5 on the x, so 3 is right here. Negative 5 over here. Y-intercept is negative 30, which is way down here. Negative 30. So our graph should look like this. Okay? And the last step will be to check. Do we know how to check? Okay? But since I did it with you, I'm not going to check just so that we can go on to the next one. Okay? So check this out. On the homework, you're going to get stuff like this. Everybody look up, please. Look at this one. Didn't they do most of the work already? Yeah. What's left? Set each one equal to 0 and solve. Yeah, let's look at this one. Set each one equal to 0 and solve. How about this one? Everybody look up. Hold on. Everybody look up. Look at this one. This one, we need to have everything on one side, don't we? And the other side has to be equal to 0. So what do we need to do here? Subtract 21. Subtract 21. We're left with x squared plus 4x minus 21 equal to 0. And the rest is pretty much just a variation of all that. What's that? There's no y because we already made it into 0. So our homework, what was the page again? 579 to 580, numbers 1 through 49? 43. 1 through 43, odd. Have a good one, guys. Enjoy your homework. Turn in your homework on your way out. See you guys tomorrow.